Um, Hi everyone. My name is Olawale Abimbola. I will just share my video for a while because of the internet. Um, so if you don't see my video, just know I turned it off. Okay, I'll share my screen. Can you let me know if you can see my screen? Just a minute, please. Okay, can everyone see my screen?
Yeah, can see it from my
Okay,
end.
perfect, perfect. Yeah. So my name is Olawale Abimbola. Just like I said, I am here to talk about recommendation systems. Actually, this presentation, I have done it like I've presented something like this in different places, in conferences, um, locally and internationally. And I'm here to talk about recommendation systems again because I am actually it's majorly what I do daily, and I'm in that domain. I currently work with Creative Advanced Technologies in Dubai, and re- I was recently endorsed as Global Tech Talent in Digital Technologies, and I am interested in ML, deep learning, computer vision, and Rexis. I love research. If you have the opportunity to go through my profile, you see I have collaborated with a couple of people in developing top-notch research articles and papers which are published in top academic journals and are presented in top conferences. Um, Here you can actually connect with me if you want to, and I will be available to answer any of your questions. So this here is our outline for today. We'll discuss about what recommendation system is, the types, collaborative filtering, sorry, content-based filtering, collaborative filtering in terms of item-based recommendation, collaborative filtering in terms of um, collab- I will also talk about collaborative filtering, but this time it will be user-based parts, and I'll talk about market basket analysis, and we'll probably have a little demo. I don't know how much time we are going to have, but I created a little demo to just explain a little of what I have been discussing, and hopefully we could do the demo. So what exactly is recommendation system? Um, Particularly for me myself, I don't know. Um, I don't have a definite definition, but I would put it this way: if you are in a situation where, I don't know, it happens to me most times, right? And where I'll be in a situation where I have to choose a movie to watch, and sometimes I just find it hard to find a movie on Netflix or probably YouTube or something, and so that is basically you are doing the work of recommendation system because you actually don't you are actually trying to find a movie to watch, which is a product, and the movie or the product, yeah, I'll put it that way, um has to satisfy you one way or the other, and you have to be very much interested in it. And this is one of the issues that comes up when it comes to recommendation systems. And particularly, I don't know, there are different scenarios, like why is it difficult to decide on what to watch or purchase, you understand? And it's a big question generally, and one of the major issue is um as a person we actually struggle to explain our taste. What I mean is you you might remember the movie you like, right? But you don't exactly know the features or what exactly made you like those movies. Another thing is choice overload. If you could remember when you get to Netflix, there are a lot of, even though there are recommendations that are particularly for you based on your interaction with the platform, there are still choice overloads where you have issues, so to say, to like select or make decision on which movie to watch. And in that context, recommendation system is just possible to help us to leverage on our weaknesses and be able to make decision even when we by looking at some of our interactions with the platform to be able to make some best suggestions to us that would satisfy our needs. Recommendation system is not may not be new to everybody, but if you could think of recommendation system, these are lists of platforms which is being used in e-commerce when you go to your Jumia, Walmart, Amazon, etc. On streaming platforms like YouTube and Amazon Prime and some of the other ones that are here, and on social media, for example, TikTok recommendation system, TikTok recommendation engine is top notch. Instagram is top notch. I love their recommendation engine actually, and I've read like some of their papers on how it was built and stuff like that. So when we talk about types of recommendation systems, we have the content-based filtering, the collaborative filtering, and the hybrid. The hybrid is more of combining the content-based and the collaborative-based. And apart from that, okay, let me just move forward. And when we talk about recommendation system, while building recommendation system, part of the our data, the data used in building recommendation system are of two types. It is an explicit feedback kind of data or an implicit feedback kind of data. What do I mean by this? For the explicit, we are trying to use informations that are gotten from reviews, from majorly around reviews or the major how do I put this? Major feedback from the user. Let me put it that way. Yeah, feedback in form of reviews, ratings, likes, etc. But when it comes to implicit kind of feedback, where we talk about the kind of data we use in building our recommendation systems, we are talking about the interactions of users with the platform, such as what you've checked before and you did not buy, and history, browsing history, what you purchased before. So probably we might be, a recommendation system might be built in the sense that it might tell you, okay, probably you need to get this again, thinking you've actually used you finished using what you've purchased before and you might need it again. What for streaming platforms, the songs you've played before and etc. So I'm sorry I have to come to this so that we can understand the concepts actually. So majorly this is a user item matrix of a proposed data for recommendation system where we have users and probably the items they've purchased. So this and as regards that, if we try to build a matrix vector on it, like what do I mean by this? Mostly when we are building recommendation system, like for the basis, it is majorly around distance metrics, and that is if we are not using deep learning and ML, so to say. deep learning, sorry. So we are majorly looking at using distance metrics to calculate the distance between the item that you want to purchase and how similar it is with the item in the platform, other items in the platform. I will come back to this to explain more so that you understand what I mean by this. However, the major metrics used in recommendation systems, like the item based, the little ones, like the ones that are not very, very the ones that are not very, very complex, are the distance metrics, which are the cosine similarity and the Euclidean distance. I'm not sure if everybody understands a lot of mathematics here, but this is not really much math. The cosine similarity is based on the distance between the two products, which is A and B, and it's calculating based on the angle. And the Euclidean distance is majorly the distance between A and B, not the angle in this case. And the formulas are here where if we want to explore them. However, I will talk about the content-based filtering. And the content-based filtering is actually how do I put it? Let me put it this way in a layman term. You are getting a recommendation based on the similar products. What do I mean? If you select a product, probably on Amazon, for example, a shirt, just like you're seeing on the screen, you get different recommendations just like this based on the shirt you've selected. And this is just basically a content-based filtering. It is filtering it based on the content. It is selecting a product which actually is an item, and it is calculating the distance metrics between all of other items in the platform and be able to select the top similar item based on probably the cosine similarity and the Euclidean distance. For example, if this is my product A and this very first shirt is my product B, I'll go back to my calculations, the metrics I was showing to you before. The item interaction matrix, this is for the item 1 and this is for the item 2. So it calculates if item A is the first shirt and item B is the second shirt, it calculates the distance between the first shirt and the second shirt, right? And be able to make, based on the cosine similarity or probably the Euclidean distance, you can select one out of the two and be able to make your decision for you. And it will calculate it for all the items in the platform and be able to select the top best of the product, probably the highest top similar ones, maybe top 5 similar ones, or top 10, depending on what you want when you are building your recommendations engine. This is another example of content-based filtering, where you select a TV and you get a list of televisions that are actually related to this. It is just trying to show you something that is very, very similar, such that you'll be able to have varieties of products, so that you will be able to have variety of products to select from, and something like that. The next thing I'll be discussing is collaborative filtering based on item in relations to item-based recommendation. Collaborative filtering is not like content-based. Collaborative filtering is combining interactions of the users with the product itself. For example, the likes, or what people has gotten before and stuff like that. So if you can see in this chart, this is a person this is a type of dog that has been recommended to a person, and this particular dog has been recommended because um this person has liked on the platform has liked um different species of dogs, like different species of dogs and stuff like that. So okay, I'm coming. And that is one of the things it looks like. You might be your item-based collaborative filtering might be based on what you've liked before, your interactions with the platform. Probably it is from the explicit form or the implicit form, and be able to combine all of this together to be able to make a recommendation engine for you. This is based on user, and this is a very good example of how a user-based recommendation work. For the first line, we are seeing a person named Jake, and on the platform, okay, sorry, by saying platform, it can be an e-commerce platform or a website where this particular person is getting this product. So this person named Jake got a ball, a sunglass, and a pair of flip-flop. Fumi got a bikini and a flip-flop. Actually, they are going to the beach, I guess. Nike, Nike got um a ball, sunglasses, and a flip-flop. So Joanne, for Johanna, what would be recommended to Joanna? This is how user-based recommender system collaborative filter works. It combines what other people has gotten. For example, other people on the platform that actually got something that's related to what you got it, and to recommend it will recommend stuff that you are not getting. So for Jay, Fumi, and Nike to have gotten flip-flop, there is high probability that Johanna will be getting a ball, a sunglass, and probably a bikini because Johanna is a lady actually. So that is how user-based recommendation works. Like, yeah. So that is basically how it works. It gives you recommendation based on what other people that have gotten the product you want to get based on what they've gotten with the product. So if Fumi has gotten a flip-flop, there is high probability that there will be a ball, a sunglass, and probably a bikini recommended to Joanna. Then market basket. Market basket is quite interesting. It actually combines, or how do I put it? Just like the name, a market basket. It's a form of recommendation system that try to recommend items used along with the product. If you can see in a shopping basket, customer one is having a milk with bread and cereal. Customer two is having a milk with bread, sugar, and egg. Customer three is having a milk with bread and butter. And the other one is probably sugar and egg. And if you look at all of these scenarios, you see that all these products that are in the basket are actually products that the customer might use alongside each other. Milk goes along with bread and cereal, if I'm not wrong. Sugar, milk, bread, and egg goes together. Sugar and egg goes together. So these are things you use together, like you can't do without, like when you are shopping. What market basket does is it tries to recommend items that you can use alongside the product you're getting. That is basically what market basket does. And majorly market basket analysis, a priori algorithm, it's something, it's an algorithm we use basically majorly in market basket. And this is a very good example of how market basket analysis works. Sorry. yeah, how market basket analysis works. Um, you are adding a product to cart. If you are familiar with e-commerce, you see immediately you add a product to cart page. You get other recommendations of what goes along that particular product. So, for example, this you added an headphone to the cart page, and you get different recommendations, which says which are PlayStation, USB hub, gamepad, and stuff like that, which are something that you can use alongside with the headphone you've gotten. This is another example. I mean, sorry, can you still see my screen?
Yeah,
Hello.
yeah, I can see
Yes,
your
I
screen.
can.
Breaking a bit.
Okay. Thanks. Okay, so market basket, market basket analysis. Okay, yeah, this is another example of market basket where you select another product, um, which is a keyboard, and you get a lot of how do I put it? You get other recommendations such as a USB hub, a CD-ROM, a mouse, stuff that you can use alongside the market basket. Sorry, the keyboard rather. So that is basically the major recommendation systems that actually exist. Other ones are fashion recommendation, um, yeah, fashion, yeah, where you for example on AliExpress you saw a product, you snap it and you upload it to the platform. Um it's able to give you some other product that looks alike with the product you've seen or you want to get. So those are some of the products, some of the types of recommendation systems that exist. So I have a little demo. It's not something big, but it is something around um, collaborative filtering, item-based collaborative filtering. Um, I don't know if you can. I'll copy and paste the direct link. I'm coming, please. Just saw this online somewhere. I pasted it on the chat window for anybody that wants to get it. Hello? I dropped it in the chat window, so if anybody wants to check.
All right. Yeah, seen that, sir.
Okay,
Yeah, I've been able to access it. Thank you.
okay, great. So just a minute. Yeah. So this is it. It is just a recommendation engine, a recommendation system that was built. I am actually using an open source data. This is the popular movie data set. I just put it up from one of the GitHub repo that I saw it. and this is where we imported data. And one of the issues with this is we have a lot of for now. What I'm trying to do is just to introduce you to some part of recommendation systems, which is the item based recommendation system. So I'll be using the collaborative filtering and which I talked about, and the cosine similarity. So I'll drop some of these features. I'm selecting the useful one. I don't know why this thing is dragging. Of interest to me, which are keywords, the cast, the genres, and the director. Actually, I believe these features are actually very important to a movie which you want to watch, because you might have a favorite director. It might be a thriller or an action movie or whatever. And I believe that was the reason I believe some of the features, and actually just for as it is. So now the next idea was to combine these features together, like combine features with the cast, with the director, and so on. And after combining, if you can see, actually, you can run the script. It's something you can run, but I don't think I want to run it. I'm just trying to explain. I don't know why this is trying. I'm so sorry. If I thought the cast, the everything together, which I title and etc. together. After that, the next thing we need to do is to introduce a word embedding model. I did not make mention of that in the slides. However, I'll talk about it here. After combining those features which we think are very important to the recommendation system, or to the recommendation system in general, we cannot calculate the similarity or distance based on textual data, TF-IDF, count vectorizers, and so on. And what this does is actually convert this textual information into a numerical form, such that you'll be able to do the main computation you want to do. So that is what I did. I made use of count vectorizer, which is, and I applied count vectorizer on the combined features, and after which I was able to calculate my similarity matrix using cosine similarity. And by doing this, I created my recommendation function, right? Which I'm coming, and the function is just to, after updating the index, any selected movie, I select, the top it's okay. Immediately I select the movie, it calculates the distance based on the similarity matrix and cosine similarity, and be able to select the top movies that are related, that has the highest distance, highest similarity with the particular movie I selected. So that's what, just a minute. If we will see this, I selected a movie which is Dark Knight Rises, and these are other products, or I'm sorry, other movies it was able to recommend for me. Let me see if I can try another one. Forming. I don't know why.
Yeah, and sorry, your voice is really breaking,
Having
Mr. Lawley. We can't really hear you very clearly.
this is happening. Yeah. Maybe because I'm using. Okay. But can you hear me now?
Yeah, we can hear you now. Yeah, can hear you now.
Hello.
You're very clear now. Can hear you now.
Hello. Can you? Okay, perfect. So you can see this is another trying to select a movie.
Sorry, you are completely breaking now. We cannot even hear any single word.
Jeez, I'm not on this PC in this. I'm coming. I'm trying to select. And actually, you can try it from your own end. You can try to run the script. Why can't you hear me
Yeah, we can hear you.
now?
I can hear you now very clearly.
I'm coming. I don't know what is happening, but maybe I'll try to leave the call and join again so that you know.
Okay. All right. All right, guys. Sorry for the network glitch, the sensor network glitch. So let's just be patient and let's wait. I'm very sure it will be rectified very soon. But I am very sure. So we are also learning a lot. I know for some of us, this way ahead what we've learned or what we know. But the purpose of this webinar is to expose us to new information and definitely things that are really above us, to expose us to things in the industry. So just do well to stay tuned, be patient while Mr. Olawale rectify the technical glitches he's experiencing. Thank you very much.
So can you hear me?
Yeah, we can hear you now very clearly, sir. You're
Okay,
welcome back.
I am sorry for that glitch. I will reshare my screen. Coming.
All right.
So just where I stopped, I talked about the recommendation function, and what it does is when you select a movie, it calculates the distance between excuse me, it calculates the distance between the movie you selected with all other movies in the system and calculate the similarity between each and every one of them. And at the end of the day, it selects the highest 5 or 10, um, highest 5 or 10, and it displays it. So for example, this is one. Let me see if I can try and do this. I'm trying to select the movie. I selected Spider-Man 3, and I have different other movies that are related to Spider-Man 3. I have Spider-Man 2, I have Hancock, I have Spider-Man. I have different movies that are closely related to that you can watch even after watching Spider-Man 3 and stuff like that. So this is basically how recommendation systems work. If you have any question, we still have some time, I can answer. Thank you for having me.
Uh, all right. Thank you very much, Mr. Lawale. I guess we can now have question popping now. Thank you very, very much. That was so explicit. I know how complex recommendation systems are, and for you to break it down, I mean, to the list of us to even understand. Thank you very much. So, if you know you have question, just yeah, raise your hand, then I will just pick you. So I think first we have Akinola Babalola. Yeah, over to you. Your question.
Thank you, Mr. Dominion. Good evening, Mr. Olawale. Thank you.
Good
The
evening.
session was really, really informative. I must say I learned a lot. I have 3 questions. So,
Okay.
yes, the first one is, what's your recommended flow? Sorry for that, pun intended. What's your recommended flow when trying to design a recommendation system from the ground up? Like, what's your system design flow like? So, take for example, I have this project where you want to design like an e-commerce system,
Okay.
but yes, you're designing an e-commerce system, but you want to, as the AI engineer on ground, you want to put in recommendation capabilities into the system. Now, one of the major issues to that system is the fact that to a certain extent, you need to be able to train your AI agent with related data to what it's going to be doing in real life for it to be able to like generally adapt to new cases scenario. Do you get what I mean?
Yeah, I
Yes.
understand clearly.
Yes. So how do you navigate that situation? So is it that you do something that gives the model like the learning capability already, then introduce it to new and live data on the website? That's the first question.
Okay.
And like secondly, the demonstration link was really, really quite very explicit and, very, very detailed. So my own question now imagine you're dealing in a real life scenario, how does the cosine similarity, how does the search in code work? Is it that you convert all your let's say as your the e-commerce website, for example. So you mean as you keep updating the items you have for sale on your system, on your
Mhm.
e-commerce site.
I know
Do
you're
you,
coming to that. Okay.
sorry?
I know you're
Yeah.
coming to that.
Okay, yeah. So do you keep, so let's say you have like a batch of, okay, these are 50 things on my system. So is it that you have a script, or probably you run a script that maybe every hour convert those textual data like into like vector embeddings, then you store somewhere in the bucket, then probably your script runs, extracts and loads that the vector embeddings into your model that
Okay.
generates the recommendation basically. And the third question is, how do you handle scalability when you're interacting with like a large system? So let's take, for example, what we are learning here right now. We want to go and impute it in like a real world active scenario. Thank you.
Okay. I'll start from scalability. That is the first thing I remember from your questions, because the questions are kind of much, but I'll try and answer it efficiently. Thanks for the good question. Those are the things we see when we work with production. For scalability, after building your recommendation systems, right, you have to test. And after building the recommendation system, let me put it that way, you develop an API, REST API, for instance, and you need to be able to test your REST API. Maybe you test it based on load tests. I don't know if you understand what I mean by load tests. Load tests where you simulate high number of users accessing the API at once. I can actually share you something that I worked on load tests using low cost. Actually,
Okay.
I presented it in another webinar just like this, but I dealt with load tests for recommendation system after deployment and after creating the whole API. So low cost is a framework that you can use to do a load test on your API such that you can use it to benchmark. You test it probably on your dev or staging environment, and you can use it to benchmark your API such that you know that when this thing gets to the production, it will actually survive. So you can benchmark, you can test your API maybe by using 1,000 or 2,000 people accessing the API at once, requesting, and you check the response time based on the milliseconds it responds to you and stuff like that. So load test is what I recommend when it comes to scalability. So if your API is not responding so fast, you need to do batch recommendation if possible. So you're not reading directly from the model. You can actually do a batch recommendation where it generates all the recommendation on the e-commerce and store it as a probably, I will not say JSON because JSON sometimes will end up being heavy, maybe a paraquet file or a feather file, and you save it in the bucket. Then the API access it directly from the S3 bucket and be able to make the recommendation. It works faster that way because those are things I've worked with and has actually worked for me when it comes to production based.
Okay.
The second question, honestly, I forgot.
I can just take it over again if you want.
So I think you just state one, then when you answered, then you state the next
Yes,
question.
can you summarize the second question?
Yes, the second question was how does like the whole technology, how does it work behind the scene in a production environment?
Okay. Yeah. Okay, I got that. So in the production environment, it's this thing I showed you is something else. It's just a demo, right?
Exactly.
But in the production environment, it is different. How it works in the production, it's more of after you are sure you built your model, you create an API. And another thing with recommendation systems model is that they go obsolete quickly. Like within an hour or 2 hours, the last model you built is obsolete.
Yes.
It's obsolete because there are new transactions being carried out, there are new products that are coming in, and all of these things happen just like in a jiffy. Like by tapping your finger, all of these things has happened, and you have a lot of new transactions, new products, and all of these things. So what I do or what I have done when it comes to production based is I create something like a retraining pipeline.
Okay.
A retraining pipeline. How does it work? You train your you have a pipeline for your ETL, which pulls the data directly from the database, pre-process it, and sends it to a bucket. That I believe it's one of the best practices.
Okay.
Then from the bucket, you pick it up. Your training data waits for it. Okay, let me put it this way. This is the best. This is one of the best way I've worked with my recommendation system in the production environment. The first stage is the ETL part.
Okay.
The ETL part pulls the data from the database, it pre-processes it, and save the pre-processed data in an S3 bucket, right?
Yes.
The training pipeline is actually waiting during that time.
Yeah.
And immediately the ETL finished, the training pipeline picks the extracted and transformed data up, do the training process, do the batch recommendation if you need to, right?
Okay.
If you need to, and sends it to another bucket for saving.
Yes.
So now it is from that bucket the API will pick it up. And it will delete the old model or the old file and pick it up from there and start reading from there. That I believe is the best. And this thing works in form of a cron job where you can host it in probably your Kubernetes environment.
Yeah.
And you set a cron job such that maybe every three hours, depending on the number of loads and the number of new data that comes in. For example, for mine, most times I set it as 3 times. Every 3 hours or every 2 hours, depending on the way new loads are coming in your system.
Okay.
So that is, I believe, is the best practice. And for the API, if you believe your API is not responding very fast, try and do load tests. Batch recommendation, I recommend, and make sure your API is well structured. You are not importing anything that is consuming the memory, and make sure your pipeline, most especially the API pipeline, is well written, maybe based on data structures, so that you are not consuming a lot of memory, because the API is one of the most important part of the um engine, because it's the one that is serving the production environment. Yeah. Do I answer your question?
Yes, you did. Yes, you did. Thank you.
Yeah.
Thank you. So I really don't mind if you could share this the second resource you mentioned about how
let me
yes.
click in my
Yeah.
GitHub.
Thank
I worked on it
Thank you very much.
2 months ago. Let me see if I can still see it.
Yeah, you skipped the first
Okay.
question.
So this first question, I did not know. The first question, please.
Oh, the first question I was saying, if you noticed, or I noticed rather, from the data set you shared to us was about was a movie data set, and most importantly, or rather, more often than not, if you go online, you find data sets around movies, songs, books, and the like. So let's take, for example, you're trying to do something into a entirely like very different field. Like I've not really seen any good data set on on e-commerce rather, as it were. So my question is, I know to a certain extent that you need good data to be able to train the model to fit into real-time real-life case scenarios. So how do you handle those situations where you don't have data that actually correlate with the live data that your model is supposed to handle? So let's take, for example, you're trying to build the next Jumia, and Jumia obviously markets a lot of product, but the data you have is always around movies or music. So I'm asking, how do you handle those kind of cases? Thank you.
Actually, if we have our e-commerce website, we have our data.
Okay.
We might not be able to build all the recommendation systems we want, but at least we can start from somewhere.
Okay.
For example, if I'm just launching a product and I want to build a recommendation system for it, for example, Jumia is just launching. It does not have any pre-existing data.
Yes.
However, I have the names of items, the items ID, and all of these things.
Yeah.
I can build a content-based filtering with that product, with that data that I have currently, without sourcing for any other data. Then when users' interaction start coming in, and when I have been able to pick up users' interaction, the comments, stuff they like, and all of those things, then I can now bring in new feature.
Okay.
But for recommendation system, it has to be strictly around the product itself.
Exactly.
You don't need to sort out for data. Even if we want to sort out for data, it might be for some other things.
Okay. Okay. So if I get you correctly, let's say in the whole system design and workflow, like stage 2 would be the actually implement or introducing like a recommendation system, and stage 1 would be getting the product ID and like metadata of the products that you're going to put on the platform, right?
Yeah.
Thank you. Thank you very much.
You're welcome. Any other question?
Yeah. All right.
Okay.
Right.
I'm not sure of your name. Is it Akinola or Babalola?
Akinola, actually.
Akinola. So I shared a repository. Can you confirm if you can have access to it? It's
Yeah.
on movie recommendation too. It's just the
Okay.
pipeline that I built. Actually, I use a lot of some other infrastructures like Docker, and inside my Docker, I have different services like S3
Yeah.
bucket of this. Actually, you can run this locally if you have your
Okay.
Docker environment.
Yeah. I will
But
try it.
if you have any issue with running it, you can contact me actually. But
Okay.
I
So,
believe it will run because everything is working perfectly. If you
okay.
just run the Docker Compose, you should be able to run it
Okay.
perfectly. Then I
Sorry.
also have the locust file.
Yeah, I saw it.
Yeah, the locust file,
Yeah.
which I am using to simulate everything.
Okay.
Uh,
Thank you.
the
Thank you very
people
much.
accessing the API. Yeah.
Yes, thank you. So I believe the API is what you use to integrate the recommendation system with the e-commerce platform or whatever platform you need.
I have not, yeah. So this is majorly around the back end, what I did.
Okay.
I do not
Okay.
have the front end, I don't have the platform, but it
Okay.
is the front end guy that will implement my API to the front end. If
Okay.
you get that.
Okay, I do get that. Thank you very much. Sorry, one more thing before you go. If you don't mind, I'm asking, like, this is on a very personal note. I'm asking, probably you have, how do I put this? You have like a service around taking people through like end to end from beginners to like very high experience level, particularly just on recommendation system. I don't know if you have such services like that. I would like to subscribe if you don't mind.
Actually, I don't have that type of service.
Okay.
However, if you are working on a project and you are stuck and you need help, I will be willing to help.
Okay.
Apart
Okay.
from that, I don't
Okay.
think I.
Thank you. Thank you. How do I reach out, please?
My LinkedIn, my email address.
Okay.
Here's my email.
Just
Thank
check up the chatbot.
Oh,
It's
thank you.
LinkedIn profile is there. I also
Thank you.
shared also on our channel.
Oh, I do have you as a connection.
Wow, nice.
Yeah. Thank you.
Any other question?
Right. So thank you very much, Mr. Olawale. I also thank you, Babadola, for those intelligent questions. So do you have any other questions also from any other person? Uh, for sake of our time, if you have a quiz, if you have a question, just okay. I think still yet from Babalola. I mean, all right. So if not from anyone else, okay. Over to you, Babalola.
Thank you. Thank you very much. So, Mr. Adewale, what's your professional recommendation? Do you advise we take recommendation system like basic ML, or we try to like implement like deep learning algorithms that can help? Is there any substantial differences between the both of them, or they both perform optimally?
Actually, this particular method which I have shared actually performs well to some extent. Though when it gets to a complex situation, you might require some other filtering, or maybe there are some there are some recommendation systems models that there are models, machine learning models that are built just for recommendation systems.
Yeah.
For example, Light FM, Alternatively Square, and some other ones like that,
Yeah.
which you can employ. And if that doesn't work well, probably you might need to employ deep learning parts.
Okay.
However, deep learning part is majorly for complex data. Maybe you want to develop a recommendation system for image. I have talked about that too.
Yeah. Live using
Yeah, for
CNN or something.
yeah, using CNN where you have to upload the image of what you like, and it will give you other images of products that are related to that kind of stuff.
Yeah.
Those are kind of stuff that are interesting, which you can do around computer vision parts of recommendation systems.
Yeah. Thank you. Thank you. Oh, sorry, one more thing before you go. I promise I'll keep it just at this. I understand that you're a very, very busy man. Yeah, you're a very, very busy man. I was just asking, I'm hoping rather you could help share materials that helped you personally, or that is helping you personally, so that we can reduce the stress of having to come in to meet you, every time to, in order not to
Uh,
disrupt your work.
Honestly, I won't lie. I don't have a definite material, but one
Okay.
of the things I do is most of my ideas are probably from reading papers that are related to recommendation system,
Okay.
and also working on different personal projects, thinking about this, working on it, and stuff like that. Those are the
Okay.
things that really helped me. And I got into recommendation system environment without knowing much about it, but I was able to improve on it.
Okay.
Yeah,
Thank you. Thank you very much, Mr.
yeah,
Lawal.
you're welcome.
Thank you.
All right. Thank you very much. I think this is really a lot, a lot and a lot. Yeah. Thank you once more, Mr. Olawale. I really learned a lot. I mean, I think I had some questions, but I think some of which have been answered. Yeah. Thank you very, very much. So I'm going to share most of the resources that I shared there, like the GitHub, the link to the collab notebook, will also be shared on our community platform, so that yeah, you could just, in case you're unable to access it here, you'll be able to access it on the platform. But we are very grateful for the wealth of knowledge you shared. Thank you very much, sir. So I don't know if you have one more last word for us as let me say tech newbies, like tech enthusiasts, and those who want to go into artificial intelligence. If you have like a word of advice for everyone here, it's many persons that are here are just starting their career in this industry. Though some person might not want to maybe focus on recommendation systems, some person might want to focus on maybe robotics or health or something. So yeah, if we really appreciate. Over to you, sir, Mr. Olawale.
Okay. Actually, I'm in the middle stage of my career, and I would say one of the things that helped me so much is about building personal projects. I do a lot of personal projects, like personally, in order to improve myself, because the best way we can learn is by working on something. And I also another part of it is research. Research is not a child's play. Like, it's not something like, though we can always start little. Without I started from like not knowing anything in research environment. Publishing in top journals and stuff like that has really helped me to grow, because I've been able to tackle real life situations in form of research and stuff like that. And we are in we are in the community. Anybody in AI sector or software engineering sector, we're in the community that is not stagnant. We always have to learn. We have to keep up. If we don't keep up, we're out of the game. So it's just about learning, learning, and learning. So if we could keep up with learning, I think the sky is the starting point.